Calculate the actual weight, buoyant force, and the apparent weight of a 5 times 10 to the negative fifth power cubic meter iron ball floating at rest in mercury. So what we need to do in the first place is we need to describe the situation in the problem. How is the object? How is the object? Is the object floating? Is the object submerged? Is the object partially submerged? How is the object for this exercise?
Floating.
It is floating, okay? It is floating. How do I know that? Because the problem tells me. It says that iron ball is floating at rest in mercury. That is the information of the problem that tells me about the type of equation that I'm going to be using. Now, in the second place, what we do is we start to do calculations. I will start from the beginning. It says calculate the actual weight. That means I need to get W actual, or what I like to call it, the actual. Okay. So according to the formulas, how do I calculate actual? Take a look. Actual is equal to the weight in the air. What is the weight in the air? Actual, it says that it is equal to the weight in the air. Weight in air. But what is the weight in air? As I told you before, the actual weight is the real weight. Okay. How do you get the real weight of an object? How do you get the real weight of an object? Okay, calculate the weight of a 10 kilogram object. How do you do that? How do you calculate the weight of a 10 kilograms object?
Mass times gravity.
Exactly, mass times gravity. So this is weight. This is real weight, okay? So the weight in air is nothing more than the regular weight that you know so far, okay? So actual actually is weight, real weight. So it's the mass of the object times gravity. That is the equation that you are going to be using to calculate the actual weight. Now, I don't know what the actual is. I know what the gravity is. I know the value, I know the given. Even if it's not given, it's a constant. But do I have information about the object's mass? Is the problem giving me information about the object's mass?
Yes.
Not directly, but with the information the problem gives you, you can get the mass, okay? The problem is giving me cubic meters. Do you remember what cubic meters are? Do you remember what cubic meters are? This is volume, okay? Volume is any length unit that is raised to the third power, okay? So because I see meters raised to the third power, I know I'm talking about volume. Okay. So if I know the volume, what formula from all the ones that I showed above, what formula relates volume?
Density.
Density. Okay. So you have the volume here in density. Now, I need to know the mass. If I need to know the mass, means that I need to isolate that mass over there. Okay, I need to isolate it. It's pretty simple, the procedure. But question, do I know the density of the object? Do I have the density of the object?
No.
How can I tell the density of the object? Where can I get that information from? Take a look here. I wrote it here. It says density is related to object's material, how the object it is made of. Okay, how the object is made of. So the object here is a ball, but not a normal ball, is an iron ball. Iron tells me the material that the ball is made of. Okay, so this iron ball right here, actually just iron, tells me about the material. If I know the material, I know the density. Where can I get the density? In the table of densities. Now, what is the density of iron? The density of the iron ball. It is right there in the table. Take a look. Iron is right here, okay? And it says that the density is 7.86 times 10 to the third power. 7.86 times 10 to the third power. But I don't know about the units, okay? I don't know about the units. To know about the units, I have to read this part from the table. Density, it is given in kilogram per cubic meter. So I'm going to write it here. Kilogram per cubic meter, okay? So knowing the density and knowing the volume allows me to get the mass, okay? Remember, this is the main formula. So if I need to isolate the mass, means that I need to move the volume that is actually dividing, I have to move it to the other side of the equation by making a multiplication. So mass is going to be equal to density multiplied times the volume. Now you just plug in the givens. Okay, and you will multiply times the volume that is given in the problem. That is 5 times 10 to the negative fifth power cubic meters. Now I want you to look at this part, okay? The units for density is a relationship where the mass is in the top and the volume is below. Now this relationship, you can rewrite it like this. Kilogram per cubic meter is the exact same, but in this way, it allows you to know that cubic meters with cubic meters are going to be canceled since they are in opposite sides. Okay? Now that you cancel the cubic meters, the mass is going to be given in kilograms. How much do you get from that multiplication? How much do you get from that multiplication? 7.86 times 10 to the third power times 5 times 10 to the negative fifth power.
0.39.
0.39. Okay. Now, this mass is the mass of the object, okay? The mass of the object, like that. So, I'm gonna move this a little bit. Okay, so with this, now I can get the actual weight, I can get it because now I know the mass of the object. So I continue with the problem and I say, actual weight is equal to the object's mass, that is 0.39 kilograms, that multiplies gravity, that is 9.81 meter per second square. How much is the actual, or the actual weight of the object?
3.83.
3.83. Now, what unit do I get when I multiply kilograms and meter per second square? That gives me a single unit. What unit is that?
Force.
Force units, and force units are Newton, okay? So this is actually 3.83 Newton. With this, we answered the first requirement, okay? Now it says, calculate the actual weight, the buoyant force. So now I'm going to look for the buoyant force, okay? Now, to calculate the buoyant force, I need to know what formula to use. According to what we stated in the first place, we have a situation for floating objects, okay? So the buoyant force is going to be also for floating objects. So according to the equation that I have here, this is the equation for floating objects. So I'm going to write it. Buoyant force is equal to the mass of the object times gravity. I wrote it right there. Okay. Now, if you're clever enough, you'll notice that the mass of the object and the gravity, you can get it exactly from the step before, okay? Because the mass of the object, we got it there, okay? So if you substitute by the givens, it's going to give you the exact same answer. Buoyant force is going to be equal to 0.39 kilograms times the gravity 9.81 meters over second square, and the buoyant force is going to be equal to the actual weight, and it's going to be equal to 3.83 Newton. That is something that you can get by just analyzing the data provided, okay? And then in the last part of the requirements, you have to calculate the apparent weight, okay? So right now I move into the fourth step and I need to calculate the apparent weight. So this is unknown. So how can we calculate the apparent weight? Let's see. I want to know where the apparent weight is, and it is right here. I'm gonna put it apart. Okay, it says that the apparent weight is equal to the weight that the object has when it's inside the fluid, okay? So actual weight is the weight of the object, but when it is inside the fluid. So I'm going to write it here. Weight of the object when it is inside or submerged. Okay. So what is going to be the apparent weight for this exercise? It says weight of the object when it is inside. What is the situation that we have here? Floating, partially submerged, or submerged?
Submerge.
No, it says the iron ball is floating, okay? It is floating. The iron ball is floating. Well, I have a ball right here. So imagine this is full of water, okay? If I put the ball, it will be floating, okay? Completely floating. So that is the situation that we have. But instead of this anti-stress ball, I have an iron ball, and instead of water, I have mercury. So the situation is floating, okay? Because it is floating, that means that the object is not submerged. It is quite the opposite. So the apparent weight does not exist in this case because the object is outside the fluid. So what you have to say is WAP, the apparent weight, is 0 Newton. And then you have to explain the reason. Because the object is not submerged. Remember, apparent weight is only for objects that are submerged, okay? So it's because it is floating, we say that the apparent weight is going to be 0 newtons. And with this, we answer all the requirements for this exercise. The actual weight is the real weight. The buoyant force depends on the type of exercise. We said the object is floating. The problem tells me that the object is floating right here. Okay. And with this, we are able to solve. But knowing the kind of exercise that we have is important. Because if you tell me that it's submerged, you're going to be using the incorrect equation. If you tell me that it's partially submerged, you also will be using the incorrect equation. So remember, WAP, the apparent weight, is only for submerged objects, okay? Only for submerged objects. If the object is floating, you don't need to consider it. And this is it for this exercise. I was going to give you the introduction for this one, but it won't be possible. So I'm gonna leave it like this. I'm going to send you, guys, the quiz with you is going to be on Wednesday, okay? And it's going to be about torque with forces that are inclined, okay? Forces at an angle.